Hi everyone, today we're looking at operations of functions, part 2. Today we're going to talk about a composition function. Note that composition functions literally just mean that we are compositing or putting together two functions. So here's some nice notation for you. This is pronounced f of g of x and should be very, very, um, you know, particular about that being an open circle in there. You don't want to get it confused with multiplication. So how to solve? The first thing we do is we evaluate the inner function first, and then we use this as a result for the input of the outer function. So I think probably the best bet is to just show you an example and how this actually works. In this, we're going to let f of x equal x minus 3 and g of x equal x squared plus 1. First thing that we're going to do, we're going to find f of g of x, and then after that we'll find g of f of x. So I'm going to split this into two. And first find f of g of x. And notice how this can be rewritten as f and then parenthesis g of x. Literally what we're going to do is anywhere that we have an x in our first f of x equation, we're going to take that g of x, that whole entire thing, and plug it in. Kind of similar to like just a shorthand. If f of x was 3x and g of x was 2, then we would say that f of g of x was 3 times 2, because that's where the x originally was. Instead of 2, maybe we have something like x minus 6. We just replace that x with the x minus 6. So coming back over here, first thing that we want to note is that our f of x is x minus 3. So where that x is, I'm going to be plugging in x squared plus 1. So f of g of x is now going to be x squared plus 1 minus 3, which then can simplify into x squared minus 2 once we drop that parenthesis. And that's my answer. Whether you write it as f of g of x with parentheses or with the little circle, it doesn't really matter. They're the same result. Now over here, we've got g of f of x. So now we're going to do the opposite. We are going to start out with the g of x function, which in this case is x squared plus 1. And in where that x is going to be, we're going to plug in f of x, which is x minus 3. So now, again, this can be written as g of f of x. So g of f of x is equal to parenthesis x minus 3 squared. We're only taking out the x, not the squared. The squared stays, plus 1. Now, anytime that you have an equation that has a square with it, we want to do something called factoring. We want to do something called foiling. Factoring is the next unit. So we essentially, squared means that we have two of these, so x minus 3 times x minus 3 plus 1. And then we're going to do first, outer, inner, last. So I'm going to bring this up here. We're going to do FOIL method. Okay. First, outer, inner, last. And I'm pretty sure that I spelled outer wrong, but that's okay. Okay, so g of f of x. So I'm just going to rewrite this over here. So first, the first two we're going to multiply together. We get x squared. The outer, so negative 3x. The inner, so negative 3x again. And the last, -3 and -3 become +9. And then, of course, I've got that -1 at the end. So when we simplify this, g of f of x will now become x squared minus 6x plus 8. And we can't simplify the x squared with the x because they have two different exponents. So we are finished. If you look at these other ones, again, what's nice is that you guys have the opportunity to pause and fast forward and back up, so please do. Here we go. We've got f of x, which is 4x squared, and then we've got, again, g of x is equal to -x minus 7. I'm first going to find f of g of x, and then I'll find g of f of x. So in this case, I'm starting with 4x squared, and where my x is, I'm going to have -x minus 7. So in this case, my f of g of x is equal to 4 times -x minus 7 squared. So 4 times -x minus 7 times -x minus 7. And again, we want to do our FOIL method. So in this case, I'm going to leave the 4 out here first. It's going to become x squared, positive x squared, outer, which is positive 7x, inner, so positive 7x, and then last, positive 49. Still leave the 4 out here. I'd simplify this first, make this x squared plus 14x plus 49. And then we want to distribute the 4 in. So f of g of x is equal to 4x squared plus 56x plus 196. And that'll be our final answer for that side. On the other side, we've got g of f of x. So we're going to start with the g first, which is -x minus 7. And remember where that x is where the f of x is going to go. So in this case, we're going to plug in 4x squared. So g of f of x is equal to negative parenthesis 4x squared close parenthesis minus 7. So g of x, I can just distribute that, negative 4x squared minus 7, and I can't simplify that anymore. Okay, the 7 doesn't have an x with it, so we can't combine terms. Moving through here on example number 3, okay, we're finding let g of x equal to 2x and h of x is x squared plus 4. We're going to find h of g of x, we're going to find g of h of x, and then we're going to find h of g of -2. So we're actually going to plug in a number once we simplify. First thing, h of g of x. So note that h is x squared plus 4. So where this x is, I'm going to now have a 2x. So h of g of x is equal to parenthesis 2x close parenthesis squared plus 4. From our laws of exponents, I'll distribute that. And h of g of x is going to be 4x squared plus 4. On the flip side, we've got g of h of x. Notice how I start with writing what the outside actually is. In this case, it's 2x, and then where that x is, I'm going to have x squared plus 4. So I'll have g of h of x is equal to 2 times x squared plus 4 I'll distribute my 2, and I'll get 2x squared plus 8. And then last, it wants me to find h of g of negative 2. Okay. Over here at the very first, we found that h of g of x was equal to 4x squared plus 4. So we can actually just plug that in from there and make this 4 times negative 2 squared plus 4. So 4 times 4 plus 4, which is h of g of negative 2 is going to equal 20. You can do that a couple different ways. That's probably the easiest since we already have the formula. Another way would we plug negative 2 into g of x first, find out what that number is, and then plug it into our h of x, which is also another option. Okay, so we write this over here. Option 2 is find g of negative 2, which in this case was negative 2 times 2, so it would have been 4, and then you could find f of 4. So in that case, that would have been 4 squared plus 4, which still would have given you that answer of 20. So you can break it apart, find the inside first, and then go to the outside, or if you already have everything done, you just plug it into that new formula. Okay, example number 4. Here we're finding f of g of 4 and g of f of negative 2. So this is, since you don't have to find f of g of x or g of f of x, this is the time where I would say, let's use that second option. So if I was finding f of g of 4, I would, at first, my first step, I would find g of 4. So in this case, it's negative 4 squared minus 3. So negative 16 minus 3, which is negative 19. And then I would use that to find my f. So in this case, I'd find f of negative 19 because that's what I got whenever I had g of 4. So 5 times negative 19 squared plus 1. 19 squared gives us 361 times 5. And then we're going to add 1 to that. So we get 1,806. Same thing over here. I know it's written a little bit differently, but it's still the exact same steps. In this case, though, since f is in the inner, I would my first step, I would find f of negative 2. So 5 times negative 2 squared plus 1. So 5 times 4 plus 1, so I get 21. And then step 2, find g of 21, that answer for f. In this case, negative parenthesis 21 squared minus 3. So 21 squared is 441. That's going to be a negative 441. Minus 3 is going to give me a negative 444 for my answer. Last problem that I have for you, this real life situation, a store offers a 20% discount and you have a coupon worth $3. Use the function to model the discount an item by 20% to model applying the coupon. Then we want to use a composition, how much you pay for the item if the clerk applies a discount first and then the coupon, and the composition as if you pay for an item, apply the coupon first and then the discount. So first thing I'm going to do is I'm going to model the discounts. I'm just going to label it f of x. So we're going to say f of x is equal, store offers a 20% discount. So that's really like saying that I have 1 minus 0.20 times x, which really is f of x is equal to 0.8x. Since we're taking, say we have a whole, which is 1, we're taking the percent off, which is 20, so we're subtracting 0.2 because percent is decimal. It gives us that 0.8x. And then the other one I have is g of x from coupon, whatever my amount is, I am just subtracting $3 off. So the first one says, use the composite of your two functions to model how much you pay for an item if the clerk applies the discount first. So that would be inside and then the coupon. So really what we're going to find first is g of f of x. So remember, if g of x is x minus 3, we're going to be plugging in 0.8x here. So g of f of x is going to be 0.8x minus 3. And then on letter C, we're actually applying the coupon first and then the discount. So this is really like saying that on the inside, g of x is on the inside. So f of x, remember, is 0.8x. Where the x is, we're going to plug in inside x minus 3. So f of g of x is going to be 0.8 times x minus 3. So f of g of x is equal to 0.8x minus, see here, 3 times 0.8, which is 2.4. Okay. And as you can kind of see with these answers, if you go out shopping, maybe you're going shopping to Kohl's or Target or some place that gives, cash or coupons, it might be more beneficial to apply the discount first and then the coupon instead of applying the coupon first and then the discount. Kind of remember that the next time you're standing in line, that you can use this math out there in the real world. Make sure that you complete the homework assignment associated for 2.4 part 2. I hope everybody has a great day.